Hello, I am Someone from the Dark, and welcome to Analyzing Yu-Gi-Oh! Theory. This is the first entry in a series I plan on recording, where I will attempt to explain Yu-Gi-Oh! Theory using math and statistics. Today, we will be looking at the Upstart Goblin theory, which has recently come to be known as hovin theory. For anyone who does not know what Upstart Goblin's effect is, it is as follows. Draw one card, then your opponent gains 1,000 life points. The theory presented by hovin is that by dedicating 3 slots in your 40-card deck to this card, it essentially becomes a 37-card deck, since Upstart Goblin can be played as soon as you draw it to draw the next card immediately. The 37-card deck will result in a better probability of you drawing the cards you need, and thus it's optimal to play 3 Upstart Goblins in your deck, according to hovin. I plan to do a few more videos on just hovin theory, but today we're going to focus on how playing 3 Upstart Goblin in your deck can increase the chances of you drawing specific cards in your opening hand. Before I delve into how I calculated the formulas for this, I believe it's important to talk a little bit about myself. I'm an engineering student at the University of the Pacific, and I'm pursuing my undergraduate degree. I think this is something that's important to note, since I'm not infallible. I may have made a mistake in my calculations, and if that's the case, I hope we can work together to fix that. I also think it's important to note that prior to these calculations, I believed hovin theory to be correct. I tried to focus objectively as I did this experiment, though, and not favor what I thought the outcome would be. As it turned out, the results surprised me. But regardless of my preconceptions, I think it's important to have a mathematical formula for calculating probability. And that's why I decided to continue working even when things started not looking like they were going my way. Anyways, now that we've gotten that out of the way, let's go into how I arrived at this formula. There are many ways to calculate probability, but probably the most intuitive is using combinations. The formula for calculating the number of combinations in a set of n items, where you are drawing k items at a time, is n factorial divided by the quantity k factorial times n minus k factorial. In this case, we have 40 cards in our deck. We're drawing 6 cards in our opening hand, so the equation would be 40 factorial divided by the quantity 6 factorial times 40 minus 6 factorial, or 34 factorial. So, like I said, that'll give us the total number of combinations of opening hands we could possibly get. Now, what that actually equals isn't very important. We can just plug this equation into Excel, and we can have Excel calculate it for us. And since we're dealing with probabilities, we're just going to be dividing by much numbers and getting numbers less than 1, basically, to work with. So it really doesn't matter exactly what this comes out to. We just need to know that we can get the total number of combinations from this formula. So in order to get a percentage of how many good combinations, or in this case, opening the card that you want, you can take the total number of combinations where you have that good card in your opening hand and divide them by the number of total combinations there are for all opening hands, and then multiply by 100 to get a percent. The other way to calculate this would be to take 1, which represents 100%, and subtract the number of bad combinations, or combinations where you didn't open with the card you wanted, divided by the number of total combinations, and again multiply by 100 to get a percentage. So now we have this idea of a theoretical 37-card deck. This is what we're going to be using as our baseline when we look at hovin theory. According to him, by running 3 upstarts in your deck, you can achieve percentages in probability that are equal to if you were running a 37-card deck. The total number of combinations for this deck would be 37c6. And the probability would be calculated like this. If you had 1 card in your deck, let's say we were talking about our 1 dark hole that we can run, you could say it's 1 minus 36c6 over 37c6, because 3066 is the total combination where you don't open dark hole. And 3766 is the total combinations of all your cards. So 1 minus 3066 over 3766 will give you the combinations where you do open dark hole in a percentage form, and then you multiply 100 to get that percentage. For a 40 card deck, it would be very similar, but you would use 39C6 and 40C6 instead of 36C6 and 37C6. So if we look at this, I've kind of outlined the formulas. We have 1 minus 39C6 over 40C6 times 100. And that gives us 15% chance of opening dark hole in our first 6 cards in a 40 card deck. In a 37 card deck, we have 36C6 divided by 37C6. That's subtracted from 1 and multiplied by 100. We get a 16.2% chance, about. This is actually the quantity 6 over 37. We'll come back to this later. I just wanted to note that that is 6 out of 37, because it helps explain, after we get to my formula, why in fact Hovin's theory is not a 37 card deck as he claims. So what we can do for our 40 card deck with upstarts is we can take this base percentage here, the 15% given to us by a 40 card deck, and we can add the hands where upstart helps us draw the card we're looking for, in this case dark hole. So we're going to add this section to the equation first. To think of what we're adding here, think of if your opening hand didn't contain dark hole, but it contained 1 upstart. You could think of it as one of your 6 slots being taken up by Upstart Goblin, and you have 5 slots that could be anything else. Because for this particular case, we only want there to be 1 upstart in our hand, we're going to exclude other upstarts, and we're going to exclude our target card, dark hole, from being in that opening hand. Since we already accounted for dark hole in any opening hands in this section of the equation, and we don't want to have any overlap. The total of good combinations then will be the number of combinations of all the other cards that could be in this 5 slots. So, subtracting the 1 upstart we already took, the 2 other upstarts in the deck, and dark hole from our 40 card deck, there's 36 cards left in the deck, and we'll be drawing 5 of them. We'll divide this by the number of total combinations for our opening hand to get the percentage that will open with upstart, but not 2 upstarts, 3 upstarts, or dark hole. And then we're going to multiply that percentage by what's in these parentheses here. So let's go over what each of these terms are. Well, this first term is just the chance that once you draw this 1 upstart, you'll activate it again to draw another card. And what are the chances that you draw dark hole? Well, it's going to be 33C1 over 34C1, and that quantity is going to be subtracted from 1, because that's the total number of combinations that you could draw that isn't dark hole, 33 of them, over the 34 total combinations. And you're drawing 1. Well, it turns out that when you draw 1, it's, in this case, 33 factorial over 1 factorial, which is 1, divided by 33 minus 1 factorial, which is 32. Well, 33 factorial over 32 factorial is just 33. And likewise here is just 34. So I just omitted the combination portions in the rest of these equations, where we're just drawing 1 card, to simplify things a bit, so we don't have to include them in the final equation. So as you can see, for your chance of drawing dark hole, it ends up being 1 minus 33 out of 34. This could be further simplified to 1 out of 34. But later on, we're going to make this for an arbitrary number of cards, not just the 1 card that's dark hole. So it's useful to think of it in this state. So we have 1 over 33 minus 34. The next section will be, what's the chance of us drawing another upstart? Well, there's 2 upstarts, so 1 minus 32 over 34. This time, this part of the equation will not change later, so we can replace this with 2 out of 34. And the next portion will be 1 minus 32 over 33. because that's, again, the one dark hole. And again, I'll make this an arbitrary number of cards later, so that we have a more useful equation. The last section is the 2 out of 34 for drawing an upstart, and then it becomes 1 out of 33, because that's this drawing into the second upstart, and then 1 minus 31 out of 32. Oh, I forgot to mention, the reason we're using 34 here and not 40 anymore is because we drew 6 cards. That might have been obvious, but I thought I should mention it. Since we did draw 6 cards here, there's now only 34 cards left in the deck. Likewise, after we draw an additional card off this upstart, there's now only 33 cards in the deck. And then here, it was 34, went to 33, we upstarted again, and now we're at 32 cards in the deck, where 31 is the number of combinations that isn't dark hole. So that'll sum up what happens if we open with 1 upstart. What if we open with 2 upstarts? Well, we can treat it very similarly. We'll have 4 cards. There's 1 upstart left in the deck, 1 dark hole left in the deck, and the 2 upstarts we already drew. So we'll remove those. So there's 36 other cards, and they can fill up the 4 positions. So we get 36C4, 40C6. In this case, though, we're not drawing 1, we're drawing 2 because we're going to activate both our upstarts. So we're drawing 2, so we'll have the chance of us drawing dark hole is going to be 1 minus 33C2 over 34C2, because we're taking away the 1 dark hole, and we can draw any of the other cards. Then we go to draw a card, and we get... okay, so yeah, this is where it gets a little bit confusing. I put 32 out of 34. What this actually is we're thinking of this also as being us drawing 2 cards. One of those cards, in this case, is going to be upstart. That leaves us 1 position. If we take away the upstart and the 1 dark hole, because we aren't drawing dark hole this time, that leaves us 32 out of the 34 cards that we could draw in this 1 position that's left. If that makes sense. So our number of good combinations will be 32C1 over 34. And that should actually be C2. I'm pretty sure I counted for that in the final equation. I'll have to double check it. But I think when I wrote it down, I accidentally deleted the C2. This should be 32 over 34 C2. And then after we've done that, what's the chance that in the second upstart we draw our dark hole? Well, it's going to be 1 minus 31 over 32, or 1 out of 32, since we only have the 1 dark hole. Finally, our last case is when we open all 3 upstarts. We'll have 3 empty slots, so 36C3, similar to the previous ones, over 40C6. And then we have 1 minus 33C3 over 34C3. Again, just taking away the dark hole and all the other combinations over the total combinations. So now that we got that out of the way, here's what the actual equation looks like. It's pretty massive. Now this is its unsimplified form. Like I said, I do simplify it later on. And just to make sure, let's look at that last section again, or the second to last section, and make sure that I did 1 minus 33, 2, 34, 2, plus 36. So 32, 1, yeah, okay, so I do have, oops. Let's undo that, there we go. So I do account for it here, like I said, right here, 32, 1, and 34, 2. So I didn't make a mistake in my formula. This is the correct formula, at least it's the formula that I represented on the Word document you just saw. So whether or not that's the correct formula, I believe it's correct. But if anyone sees an error in my thinking here, don't hesitate to point it out, and we'll try to fix this. I'm not sure if you can actually see that the whole equation, but I can post the whole equation as well. It'll probably be easier to look at the simplified version, which I'll show you in a little bit. But basically, what you'll notice is the equation does not come out to 16.2%. It comes out to 15.416%, a mere 0.4% above a 40 card deck. It's not very much of an increase at all. We'll look at the percent error in a little bit, but I just wanted to give you an idea that we're not even close to the probability of a 37 card deck in this case. Well, maybe it gets better if we're running a 3 of, right? I mean, surely it must be better for because you'll have the upstarts pair up with your target card more often. Well, if we go back to our equation here, the way this would change is, well, your target card, you'd have 2 more in here, so you'd have 37 out of 40. So this could actually be written as like 40 minus n. And similarly, in all these other spots where we had like this, could be 34 minus n. Now I'm not going to go and replace this for each one, but you kind of get the picture. Now if you split this up, you can say 1 minus 34 over 34, and then the minus distributes, you get plus n over 34. This actually comes out to n over 34, and it'll do something I'll do something similar for all of these, so that they're not as complicated. So let's go over to this again, our Excel spreadsheet, and here I've made a little some nice little equations. This number of copies cell can be changed, and it's referenced in all of these cells here, so that you can change how many copies you have and look at the percentage of a theoretical 37 card deck, your 40 card deck with 3 Upstart Goblins, and your normal 40 card deck without 3 Upstart Goblins. So here's the new formula. I think you can see all of it this time. And that F13 that keeps popping up is just a reference to this cell here with the number 1 in it currently. So as you can see, I've just replaced it now with 40 minus the number of cards you're running, 37 minus the number of cards you're running, etc. It's the same formula, but I've just made it more generic. Now we can change this to see what happens if we're running 2 copies of a card. Before I do that, actually, let's go back to 1. So this is where I have the actual error. We're off by, from our theoretical 37 card deck, this is how much more we have than a 40 card deck, and this is how much more a 37 card deck has than a 40 card deck. The difference between these is shown here in the actual error. We're off by about 0.8. The percent error, which is calculated as the difference between the two, so the actual error, divided by what you were expecting to get, or the 37 card deck value, times by 100 to get a percentage. We're 65.8% off. That's pretty significant. So even though we're only 0.8%, because we're actually only increasing by such a small amount, we're 65.8% off of the value. If we bump this up to 2, well, yeah, we got up to 0.72, I guess, over the 40 card deck. So originally we were only 0.4. So we do get a slight increase in the amount by running 2 copies. Upstart gives you more of a benefit. But we're still about 65% off. And the error, actual error, is increased as well. We're off by more than we were before, which makes sense because the percent error stayed the same, and we gained a little on a 40 card deck. And if you bump it up to 3 copies of a card, well, we're at 40%. We're almost a full percent. We're at 0.9% above a 40 card deck, so we're almost a full percent above. But it's not as much as a 37 card deck. would be. So there you have it. The mathematical formula that I've developed says that by running 3 upstarts, you're actually not running a 37 card deck, which is different from what I expected. They all are about 65% off of what they're supposed to be. And if someone can find a mistake, I would love to fix it, but right now it looks like Hovin's theory is wrong. You do not get to run a 37 card deck. And back to what I was saying just a little bit earlier. Actually, let's look at this. 6 out of 37. That's the percent they open with 1 card, right? Your 1 of Dark Hole. Well, if you were running a 37 card deck, then this equation here, that would have to simplify down to 6 over 37. And it doesn't look like that would happen very intuitively, at least not to me. Or we can look at this one so you can actually see the whole formula. But again, this formula would have to simplify down to 6 over 37. And it doesn't look like it does. So intuitively, you can probably figure out you're not actually running a 37 card deck. Anyways, thank you for joining me for Analyzing Yu-Gi-Oh! Theory, Part 1. And I hope in the next episode that you'll join me again to try to figure out how Upstart Goblin affects not just your opening hand, but now we're going to be looking at every card you draw throughout the game to really see how Upstart Goblin affects you over time and not just at the start of the game. So I'll be looking forward to it. I hope you guys are too. Thanks for sticking to the end of the video. I know it's been a doozy. This has been Analyzing Yu-Gi-Oh! Theory with Someone from the Dark.